Welcome back, Physics Study. This is FM1.2. Here we talk about acceleration. So define acceleration and average acceleration, solve problems involving acceleration, and you'll see very similar to what you did back in grade 10 science. So acceleration, of course, is the change of velocity, the rate at which velocity is changing. It's interesting because velocity is the rate of change of displacement over time. And if we're changing v, that is referred to as acceleration. So the change of displacement over time is velocity. If I'm talking about the rate of change of velocity per time, that's acceleration. So we can see some similarities here. Average acceleration is defined as the change in velocity divided by the change in time. So we could break that down into just simply delta v over delta t. Or of course, a change in something means final velocity minus initial velocity. And if we had clock readings, time 1 and time 2, so t2 minus t1, or if it's just an interval of time we're talking about, it's just simply delta t. All right, so let's take a look at an example. So a car accelerates on a straight road from rest to 75 kilometers per hour in 5 seconds. What's the magnitude of that acceleration? And leave it in the weird units of kilometers per hour per second. So first of all, we know that time is 5 seconds. We know that v1, the initial velocity, we're told was rest. So that's simply 0. And the final velocity is plus 75 kilometers per hour. So we plug that in. Delta v over delta t. And in my case, since I'm given two velocity values, v2 minus v1 over change in t, so it's going to be 75, technically it's a positive 75, minus 0 all over 5. So that's going to give me a final value of 15. Now, the top part, so the velocity is in kilometers per hour. And then on the bottom we have seconds. So what that means is that my velocity is increasing by 15 kilometers per hour every second. So you can look on your speedometer. Think about it like that. Increasing 15 kilometers per hour during every second. That's how much you're accelerating by. Now it's kind of a weird unit. So usually acceleration is in units of meters per second squared, which really is your velocity is changing by meters per second. And of course, if we think about meters per second over seconds, we could put that seconds as seconds over 1, invert and multiply, and we get meters per second squared. So that's where that unit comes from. So we could have changed 75 kilometers per hour. Notice here, going from kilometers per hour to meters per second, as I mentioned last time, the easy part to do that is just simply divide by 3.6 and you get your answer. So the acceleration tells us how quickly that velocity is changing. So in this case, it's increasing in the positive direction by 15 kilometers per hour every second. And of course, acceleration is a vector quantity, so it has a size and a direction. And usually if we're talking about two-dimensional motion, we're talking about moving in the positive direction or moving in the negative direction. So I could be speeding up in the positive direction or slowing down in the positive direction, or speeding up in the negative direction or slowing down in the negative direction. So we'll take a look at that. And we have to be very careful with negative acceleration and deceleration and that terminology. So the previous image shows positive acceleration. Here is negative acceleration. So be careful here. I should put a positive right here. So this car is going positive 15 meters per second, but if it experiences an acceleration of negative, notice that the acceleration is negative, velocity is positive, so it's working against us. So that car should slow down in the positive direction. So think of this in terms of, instead of thinking of deceleration and acceleration, think of it as, are you slowing down in the positive direction or speeding up, or vice versa? So we have that. let's take a look over here. So an automobile is moving to the right along a straight highway. Then the driver steps on the brakes. If the initial velocity when the driver hits the brake is 15 meters per second, as in here, and it takes 5 seconds to have that velocity go down to 5, what is the car's average acceleration? So A is equal to change in V over change in T. Okay, and we're given velocity values, so V2 minus V1 over delta T. So initially we were going 15, and we end up going 5. And that all happens in a time span of 5 seconds. Okay, so over here on top we'll have positive 5 minus 15 all over 5. So that, of course, is going to give us negative 10 over 5, which equals negative 2.0 meters per second, or meters per second squared. So, of course, that means if I'm going in the positive direction and if the acceleration is working against me, I'm going to be slowing down. What about if we are going in the negative direction? If the automobile in the previous question had been going to the left at negative 15, so notice it's going that way, and it decelerates until it's going negative 5. Okay, so I guess it was going negative 15, and then it slows down until it's negative 5. What's the acceleration in this case? So you can see it's going to be kind of vice versa here, right? So V2 minus V1 over T2. So initially we were going negative 15, but now we're going negative 5. So notice final velocity, negative 5, subtract my initial velocity. This will happen in 5 seconds. So negative 5 and subtracting a negative is the same thing as having a positive. Okay, so I'm going to have positive 10 over 5, which equals positive 2.0 meters per second. Now, the interesting thing about that, I'm going in the negative direction. So if I'm experiencing positive acceleration, again, it's working against me, so I will slow down in the negative direction. Slow down in the negative direction. Now, if I was continue to slow down until I hit 0, and if I still have this acceleration being applied, I would then turn around and increase speed in the positive direction. Okay? So that's the key thing. Look at your acceleration. Is the sign the same as my velocity? If it is, I'm going to be speeding up in that particular direction. But if the acceleration sign is opposite to the velocity, I'm going to be slowing down in my direction of movement. So that's a key thing to note. So there's a difference between negative acceleration and deceleration. Negative acceleration is acceleration in the negative direction, defined by a coordinate system. If I was already moving in the negative, I'm going to be increasing my speed. But if I was originally going in the positive direction and I experience negative acceleration, then I'm going to be slowing down. Deceleration occurs when okay, so as mentioned, if the acceleration is an opposite sign to the velocity, you know darn well that we're going to be slowing down and experiencing deceleration. Whereas if my acceleration and my velocity signs line up, I will be speeding up in that particular direction. Right, so you should be able to do the assignment. It's pretty straightforward, very similar to questions like this. So you should be able to work that, and we'll see you again.